Section 5.7, Intermediate Algebra, Factoring, a General Strategy. Factoring is an important algebraic skill, and we should follow a strategy for factoring. You always want to factor out the greatest common factor if possible. Once the greatest common factor has been factored out, if there's two terms, consider a difference of squares, and then if not that, a difference or sum of cubes. If there's three terms, we'll test for a perfect square trinomial. Otherwise, we will factor by FOIL or grouping method. If there's four or more terms, we'll factor by grouping. So let's see if we can apply that strategy. Greatest common factor is 1. Next, quick test, is it a perfect trinomial square? This is a perfect square on the first and the last term. And to know whether it's a perfect square, we multiply those square roots together of the first and the last term and then double it. If that equals your middle term, this is a perfect square trinomial, and it will factor into x. What sign will go in between those two terms? Both signs are the same. Both are positive. We look at that second coefficient, so it is x plus 10 times x plus 10, or you could write that as the quantity squared. Here we have a two-term polynomial. Is there anything common between these two terms other than 1? There isn't. First consideration, is it a difference of squares? Well, the square root is 6x for the first term. 49 is a perfect square. It is a difference, so this factors into a difference of squares, which is the product of a conjugate pair. So the square root of the first term minus the square root of the second, square root of the first, opposite sign. I had a minus, so I'll have a plus there. Next one, we have three terms. We're looking for greatest common factor. Other than 1 doesn't exist. Next, because it's a three-term, we first do a quick check on a perfect square trinomial. X squared is a perfect square, but 63 is not a perfect square. 64 would be the closest perfect square. Because we have a coefficient of 1 here, we can use the strategy of what multiplies to give us a negative 63 and adds up to give us a 62. One of these factors has to be negative, one of them has to be positive, so just starting with 1 times 63 multiplies to give us negative 63, and when you add those factors, we're looking for them to add to be 62, we got it right off the bat. So this trinomial will factor into an x minus 1 times an x plus 63. Always when you're factoring, you should check to make sure that you've factored completely. Is there anything common between these? And also multiply to make sure that they do multiply together to give you the equivalent polynomial that you started out with. In this next problem, is there anything common between the three terms other than 1? No, so there is no greatest common factor other than 1. Is it a perfect square trinomial? Gosh, it looks like it. Square root of the first term is x. 25 is a perfect square, which is 5. The test is multiply the square root of the first and last term, but we also have to double it. And if you double it, we end up with a 10x and not a 5x. So that doesn't work. The only other option we would have for factors that multiply to give us 25, both signs are the same, both negative, would be a negative 1 and a negative 25, where this would have been the 5 times 5, actually negative 5 times negative 5. That didn't work. And here, this multiplies to give us a positive 25 if we shift to our what factors multiply to give us 25 and add to give us the middle term. This adds up to be a negative 26. These are the only two options for two numbers that multiply to give us the 25. So this is not factorable, and we would call it prime. In this next problem here, we're looking for a greatest common factor. There is not a greatest common factor other than 1. A quick check. Is it a perfect square trinomial? The first term is a perfect square, as it should be. The last term, you may not recognize this, but if you use your calculator, it ends up 15 squared is 225. Both signs are the same. Both would be negative. And the test to know whether this is truly a perfect square trinomial, multiply the two square roots together and then double them. 2 times 15 times x is the negative 30x. So this will factor into an x minus 15 times an x minus 15, or you can write it as a quantity squared. In the next one, looking at these three terms, they're all even. The suspicion is that there is a greatest common factor. 2 goes in, and as you keep working up, does 4, does 8, does 12 or 16, it ends up there is a 16 common. They each also have a common x, and we can factor out the lowest common factor. So first, there is a greatest common factor, and it's always going to be easier if you consider a greatest common factor first before you start breaking it down into perhaps a binomial times a binomial. Your results will be smaller and easier to find what multiplies together to give you that. So dividing the first term by 16x to the third, 112 divided by 16 is 7. X to the 8th divided by or factored by x to the 8th ends up leaving x to the 5th. A negative over a positive when we're factoring or dividing. 96 divided by 16 is 6. X to the 5th divided by x to the 3rd is x to the 2nd. And last, 160x to the 3rd over or divided by or factored, whichever word you prefer, ends up with a 10, and x to the 3rds cancel out, leaving a 1. A quick check, I would do a distributive to make sure that we have factored correctly so far. Now we look at the results here to come up with a possibility of breaking this down further. Whenever you have a power greater than 1 on a variable, you should be suspicious that you can factor this further. And we do have that as the case, but there is a problem here. We have an x to the 5th that will not end up generating an x to the 2nd. If you look at just what two terms multiplied together in a binomial to give you a 7x to the 5th power, you could have, since it's prime, we could have had a 7x, and we could have had an x to the 4th. But when we do our FOIL, we will not end up with an x to the 2nd. Furthermore, we have other options, obviously, but if we do an x to the 3rd and an x to the 2nd, here we would end up with an x to the 2nd. That's a good sign. But we would also, when we did our outside terms, we would end up with an x to the 3rd. When you do not have a linear term squared giving you your first term as far as the variables are concerned, you cannot factor it further. So this is our final answer for the factorization of that polynomial.